हेलो गुड इवनिंग क्या हाल चाल है जनता हाउ आर यू ऑल कैन यू ऑल हियर मी फर्स्ट ऑफ ऑल ऑडियो चेक साउंड चेक फटाफट बताओ नाउ लेट्स सी कौन कौन आ चुका है वैभव क्रिश सिद्धार्थ हेलो ऑल गुड ओह हाय क्रिश हाउ आर यू ओके जोश इज ऑलवेज हाय सिद्धार्थ क्या हालचाल है जनता Now I realize many of you joined for the Sunday session and due to some technical issue, we were not able to have it, but don't worry. We have recorded the session in 1 or 2 days. We will be uploading the session. The talk show, you are not going to miss the talk show on the physics part. So वो होगी ठीक है and one more important thing, I want all of you to go through that video and also give me in the comment section what else do you want to hear about. Okay, we can get experts from any of the field you want someone like this was the first talk show regarding physics. If you want someone from chemistry, you want someone from mathematics, that what exactly is the kind of job once you pursue mathematics, or if you want someone from specific field of engineering or medical. Okay, let's say some of you want to become a, let's say, a surgeon or a radiologist. What kind of a job or what kind of work do you get? Okay, whatever, we have already many things lined up, but if you have anything, maybe some researcher from ISRO. Okay Vaibhav, let me think, means let me inquire about that. Okay, I have got some friends in administrative services, so we are in talks with them as well. Ki IAS, IPS, what exactly is their job, what exactly is their routine like, and if you want to go for that, how should you prepare? So we have so many talk shows planned up. Apart from that, be updated with the channel because we are very soon going to have one more different type of non-academic talk. Okay, there is a special guest coming up and फिजिक्स में कुछ बड़ी ही आउट ऑफ सिलेबस वाली बातों पर चीजों पर बात होने वाली है तो मजा आएगा. एंड डोंट वरी, दिस टाइम वी विल मेक श्योर कोई लैग ना हो. HCV sir will have to check whether we can get him on our channel or not, but let's try. करेंगे कुछ तो करेंगे, don't worry. ठीक है, so for that very important thing, oops, do subscribe. ठीक है, चैनल पक्के से सब्सक्राइब कर देना so that you don't miss on the notifications. सिलेबस कब खत्म होगा सुशवन? व्हेन डू यू वांट अस टू ओवर एंड द सिलेबस? वी कैन एंड इट एनी टाइम. Basically right now we are just having these quick revision and advanced concepts, and I am planning to have the detailed chapter study as well, but थोड़ा टाइम लगेगा उसमें. ठीक है, so as of now you will have to make do with the quick revision part and our advanced concepts. ठीक है, while we are working on that. चलो guys, तो आज की पार्टी शुरू करें. So how's the Josh guys? Quickly, how's the Josh? Okay, hi, wonderful. So okay, all those who are interested in joining for the long term course, there is a very lucrative offer, means very good opportunity you can say, that for this Diwali week. Okay, if you are planning to join for the long term subscription, do so definitely in during this week because you can get up to 50%, means you will be getting 50% discount. Okay, from 7th to I think it is till 14th. So make sure if you are planning to join for the long term course, पक्के से join कर ही लेना. because I'm not sure you will be getting this discount again or not. ठीक है, चलो गाइस शुरू करते हैं. Now today's topic that we are going to have is circular motion. Okay, what we are going to study today? We are going to study circular motion. Quick revision of circular motion. Now guys, circular motion is a very interesting topic. Do you know why? In fact, I do not call circular motion as it is. I have a different name for this topic. I call it masala khichdi. Basically a khichdi. एक सेकेंड. Okay. Yes. The circular motion, the topic. Okay. I call this topic as a khichdi. Why khichdi? Because there are circular motion in itself is nothing. It is culmination of three various chapters. In circular motion, you will find kinematics, laws of motion, Newton's laws of motion, and work by energy. Take all these three ingredients, ठीक है, put it on a gas stove, धीमी आंच पर 2 मिनट कर हिलाते हुए पकाइए, and what you will get is your own circular motion. ठीक है, that is why circular motion in itself is nothing but is simply a khichdi. It is combination of these three ingredients. So that is why. No, Vaibhav, that's why it is said that if you master these three topics, circular motion के लिए you do not need to study much. ठीक है, दिवाली पर you must be seeing offers everywhere. 3 पर 1, ठीक है, 1 पर 1 फ्री, 2 पर 1 फ्री. So something we have in circular motion. Complete these three topics, get circular motion free. Okay. Yeah, something like that. Now, the only thing, okay, let's study first the kinematics part. Okay, so we will start with our first ingredient, that is kinematics. Hello, Shreya. Okay, how kinematics is related to circular motion? The only important thing that you have to understand is the difference of the terms. Properties and the relations will exactly be the same, only difference जो आएगा terms. In kinematics you deal with linear parameters. In circular motion they become angular variables या angular parameters. ठीक है, कैसे? S displacement, what will it become? Angular displacement theta. Velocity, what will it become? Angular velocity. Acceleration, what will it become? Angular acceleration. The only important thing, time तो बेचारा सेम ही रहता है. There is nothing like angular time. ठीक है, time तो I'm sure you must have seen from Mahabharat times, मैं समय हूं. So time remains as it is. The only difference is the rest of the linear parameters. Displacement, angular displacement, velocity, angular velocity, acceleration, angular acceleration. Now you do not need to remember or you do not need to study any formulas for circular motion. Equation of motion, do you remember? Guys, I'm sure everyone remembers the equation of motion. Equation of motion क्या होती थी? V equals to U plus AT. S equals to UT plus half at square, and v square equals to u square plus 2as. याद आ रहा है सभी को? इनफैक्ट फोर्थ इक्वेशन आएंगे आएंगे एजुटेकर उस पर भी आएंगे अपन, ठीक है. And fourth equation of motion, displacement in nth second equals to u plus a by 2 into 2n minus 1. Okay, so all the equations, all the formulas from one dimension will remain as it is. Only difference, linear variable की जगह angular variable. दूसरा बहुत ही important difference जो आता है, remember, not exactly difference, it is a similarity. Equations of motion were applicable when acceleration is constant. यहाँ पर condition क्या होगी? अल्फा शुड बी कांस्टेंट. चमक रहा है सभी को? चलो गाइस, गिव मी अ चमका क्विकली. चमक रहा है तो चमका लिखो फटाफट. Webber, it is dimensionally correct because this is not displacement, this is displacement in 1 second. That is a very common doubt. I hope it is clear now. ठीक है. अच्छा, if this angular acceleration is not constant, तब क्या करेंगे? If angular acceleration is not constant, we can always go back to our standard formulas. V equals to dx by dt. A equals to dv by dt. या A equals to v dv by dx. ठीक है. These are our standard equations of one dimensional motion. You can use as it is, only terms change होने वाले हैं. Formulas का pattern are exactly the same. चमक गया सभी को? चलो, very good. Now I hope basic फंडे सभी को clear है. Now moving to the next important concept, guys. Quick revision में I am not going to revise the entire chapter because practically it is not possible. ठीक है. In 30-40 minutes, if we try to revise the entire chapter, that does not make sense. More importantly, what I will be giving you is the important points of the chapter where most of the students make mistake or have confusion. ठीक है. वो पॉइंट जहां पर सबसे ज्यादा गलतियां करते हैं और द स्टूडेंट्स आर मोस्ट कंफ्यूज, दैट पार्ट वी विल बी फोकसिंग अपॉन. ठीक है. सो दूसरा इंपॉर्टेंट प्रॉब्लम जो होता है, different types of acceleration. So before talking about acceleration, relation between linear and angular variables. ठीक है. बेसिक फंडा, आई एम श्योर एवरीवन रिमेंबर्स. लीनियर डिस्प्लेसमेंट, लेट्स कॉल इट बाय एस, इक्वल्स टू आर थीटा. यू डिफरेंशिएटेड, व्हाट विल यू गेट? स्पीड इक्वल्स टू आर ओमेगा and acceleration equals to r alpha. These are some basic formulas which everyone knows. But do you know which acceleration is this? A equals to r alpha होता तो है, but which acceleration is this? A कौन सा वाला acceleration होता है? Do you know? Remember, this acceleration basically changes the speed, and that's why it is tangential acceleration. And now guys, this brings us to a very important point where most of the students either make mistake or are confused. There are many different accelerations. In circular motion, there are many different types of accelerations. So, what No, Vaibhav, not normal and tangential only. There are other types of accelerations as well. It is very, very important to understand the purpose of each and understand the difference between them. What are the different types of acceleration? सबसे पहले आता है centripetal acceleration. Centripetal acceleration, it is equals to omega square into r, or it is equals to v square upon r. This is the most important acceleration of circular motion. Without centripetal acceleration, circular motion हो ही नहीं सकता. Is my point clear to everyone? चलो guys, give me a चमका. No, no, no. बड़ा भयानक ब्लंडर कर दिए हो. Centripetal acceleration is not the same as centrifugal. चलो. Edutaker. यार ट्रैकर. बाप रे यार, अच्छा नाम रख ले, थोड़ा बोलने में इजी रहे. ठीक है, चलो. आई एक्सप्लेन द डिफरेंसेस, डोंट वरी. ओमेगा स्क्वायर आर या फिर वी स्क्वायर अपॉन आर, पहली इंपॉर्टेंट चीज. ठीक है, इट इज रिस्पॉन्सिबल फॉर चेंजिंग direction of velocity. Centripetal acceleration का एक ही काम होता है. It is responsible for changing the direction of velocity. Magnitude we have learned. Direction जो रहेगा, it is always towards the center. ठीक है, डायरेक्शन ऑफ सेंट्रिपिटल एक्सेलरेशन इज ऑलवेज टूवर्ड्स द सेंटर ऑफ द सर्कल. यहां तक आई होप सभी को क्लियर है. दूसरा जो एक्सेलरेशन होता है, दैट इज एटी, विच इज कॉल्ड टेंजेंशियल एक्सेलरेशन. टेंजेंशियल एक्सेलरेशन जो होता है, इट इज इक्वल्स टू dv by dt mod, and it is responsible for changing magnitude of velocity. Is it clear to all? Tangential acceleration is responsible for changing the magnitude of speed. तो इसकी जो डायरेक्शन होगी, it will be either along v or opposite to v. मीन्स डिपेंडिंग वो स्पीड को बढ़ा रहा है या कम कर रहा है. इसके अलावा गाइस, देयर आर टू मोर एक्सेलरेशन, एंगुलर एंड नेट एक्सेलरेशन. सो ओवरऑल इफ यू सी इन सर्कुलर मोशन, देयर आर 4 एक्सेलरेशंस: सेंट्रिपिटल, टेंजेंशियल, नेट एंड एंगुलर. तो टू अंडरस्टैंड ऑल ऑफ दीज एक्सेलरेशन गाइस, देयर इज अ वेरी वेरी सिंपल स्टोरी. The best way to learn any concept is story समझो. You are never ever going to forget the story. Story बड़ी ही interesting है. And उसके बाद all the types of accelerations will be very clear to you. So कहानी की शुरुआत होती है सदियों पहले से. एक आदमी था जिसका नाम था acceleration. There was a guy whose name was acceleration. ठीक है. Now this acceleration had a very big business empire. ठीक है, what was his business empire? To change velocity vector. ठीक है, acceleration का he had a very vast business empire to change the velocity vector. Now when he grew old, acceleration, when he grew old, he divided his entire business empire into his 2 sons. He had 2 sons, or let's consider feminism, so 2 daughters, whatever you want. No gender biasing. Okay, so one of the sons' name was centripetal acceleration, and another son's name was tangential acceleration. ठीक है, he had two sons, एक का नाम था centripetal acceleration, दूसरे का नाम था tangential acceleration. Okay, now centripetal acceleration, now he wanted that these two sons, they should not interfere in each other's businesses, so he gave them totally different departments. Centripetal acceleration, he gave it the responsibility that you will change only the direction of velocity vector. Centripetal acceleration was given the responsibility, by your company will only be changing the direction of velocity. Tangential acceleration was given the responsibility that your company will change magnitude of V vector. Okay. So tangential acceleration's company was given the responsibility that you will only change the magnitude of acceleration. Now since he do not wanted them to interfere, that means vectors yaad karo, both centripetal acceleration and tangential accelerations are perpendicular to each other. That is why centripetal acceleration always acts in the radial direction and tangential acceleration always acts along the tangent, so that they do not interfere with each other. याद करो kinematics में mutually perpendicular components do not interfere with each other. Now यहां तक तो क्लियर है. अब सर्कुलर मोशन में द पर्सन because they do not want to interfere with each other, ठीक है, उसका आगे रीजन आएगा. In circular motion में the person acceleration, he had a little biased thinking towards centripetal acceleration. Centripetal was his favorite son. So centripetal acceleration, he was given such a company that without him, or whenever circular motion is taking place, whenever circular motion is taking place, centripetal acceleration की company will always be employed. Without centripetal acceleration, circular motion हो ही नहीं सकता. Tangential acceleration might be there, might not be there. Okay, guys, यहां तक की स्टोरी क्लियर हो रही है सभी को? Come on, give me a चमका, quickly, quickly, quickly. यहां तक का सभी को चमक रहा है तो give me a चमका quickly. इन सर्कुलर मोशन की बात करें अपन, तो सर्कुलर मोशन में AC विल ऑलवेज बी देयर, AT में और may not be there. Tangential acceleration was not the favorite son, so उसकी कंपनी को ऐसा काम दिया कि कभी काम आता था, कभी काम नहीं आता था. Sometime it gets project, sometime it does not get projects. But tangential acceleration had a very fast friend. He had a very close friend called angular acceleration as well. Okay, so he employed angular acceleration in his own company. But what did he say? Bhai, I will be able to give you work only if my company gets work. If my company does not get a project, I won't be giving you any work. Okay? यहां तक की कहानी क्लियर हो रही है? चलो guys, give me चमका quickly. यहां तक का फंडा क्लियर हो रहा है सभी को? Okay? चलो quickly. That is why tangential acceleration and angular acceleration are always related. What is the relation between the two? AT equals to alpha into R. ठीक है? It is not necessary कि angular or tangential acceleration will always be there, but if tangential is there, angular will definitely be there. हाँ, सेंट्रिपिटल तो बढ़िया नोट छाप रहा है. His company is always getting projects in circular motion. And after all this business strategies and all, who is MD of the company? MD of the company is still net acceleration. Both the sons are still reporting to him. See, this is V. So let's say tangential is along this, and the resultant is the MD. Both the sons are still reporting to the MD. So A net will be equals to AC square plus AT square. And guys, this story you are never ever going to forget. By this one story, you will understand all the 4 types of accelerations and their relations as well. चमक रहा है सभी को? चलो, give me a चमका quickly. चमक गया होगा सभी को अब तो. And now you are never ever going to forget this story. चाहे सेंट्रिपिटल एक्सेलरेशन, टेंजेंशियल एक्सेलरेशन, एंगुलर एक्सेलरेशन और नेट एक्सेलरेशन, सारे एक्सेलरेशंस क्लियर है अब. ठीक है. सो दिस वाज ऑल अबाउट काइनेमेटिक्स. पहला पार्ट अपना कंप्लीट हो गया. चलो, मूविंग ऑन टू द नेक्स्ट कंसेप्ट. ओप्स सॉरी, क्वेश्चन. चलो ट्राई करो. क्वेश्चन आ गया तो लेट्स ट्राई क्वेश्चन. Come on, quickly, guys. Horizontal, Vivek. Vibhav, sorry. Constant speed चल रहा है. It is a horizontal motion. Horizontal circle. Come on, quickly. कोई क्या बात है, इतना टाइम थोड़ी ना लगेगा यार. यस, जी को तो 10 ले सकते हो. सेंट्रिपिटल एक्सेलरेशन हॉरिजॉन्टल डायरेक्शन में कितना होगा? वी स्क्वायर अपॉन आर. वैल्यू कितनी आएगी? 900 किलोमीटर्स पर आर इंटू 5/18 करो. 900 into 5/18 V square whole upon R. R is 9 kilometers. काटा पीटी करो, कितना बचेगा? दिस इज 10 गया यहां पर. ओवरऑल कितना आ रहा है? 18. 5 तो 125 अपॉन 18 मीटर्स पर सेकेंड स्क्वायर. इसमें कोई भी कंफ्यूजन? AC equals to 125 upon 18 मीटर पर सेकेंड स्क्वायर. दिस इज सेंट्रिपिटल एक्सेलरेशन. G की वैल्यू वी ऑल नो डाउनवर्ड डायरेक्शन में कितनी होगी? 10. तो व्हाट विल बी द रेशियो? 125 अपॉन 180. अब इसको जैसे चाहे सिंप्लीफाई कर दो. इज इट क्लियर टू ऑल? चलो, वेरी गुड, नाइस. एक और क्वेश्चन ट्राई करते हैं. इनफैक्ट ओके, चलो ट्राई दिस क्वेश्चन. गीतिका सर्कुलर मोशन चल रहा है एंड गाइस देयर इज अ वेरी वेरी इंटरेस्टिंग स्टोरी कमिंग अप. मजा आएगा. चलो क्विकली 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 ट्राई दिस क्वेश्चन देन विल मूव टू द स्टोरी. ये थोड़ा सा प्रिंटिंग मिस्टेक है. द न्यू वैल्यू ऑफ स्पीड एंड एक्सेलरेशन पूछा गया है. चलो क्विकली. चलो बाकी जनता फटाफट फटाफट. ओनली वन आंसर. ओनली वैभव हैज आंसर्ड. बाकी जनता. चलो चमक रहा है सभी को. रिमेंबर द टर्न टेबल इज रोटेटिंग यूनिफॉर्मली. यूनिफॉर्मली मतलब ओमेगा इज फिक्स्ड. सो यू हैव टू फाइंड द न्यू वैल्यू ऑफ स्पीड एंड एक्सेलरेशन. यार चंपू सा क्वेश्चन है. v equals to omega into r, रेडियस हाफ ऑफ इट्स ओरिजिनल वैल्यू. रेडियस अगर हाफ हो गया तो v विल ऑल्सो बिकम हाफ. What is the formula for acceleration? Centripetal acceleration omega square into r. Again radius half हो गया तो AC will also become half. तो करेक्ट आंसर कितना आ जाएगा? ए. चमका सभी को. इज इट क्लियर? चलो वेरी गुड. अब बात करते हैं एक और बड़ी ही इंटरेस्टिंग स्टोरी की. Now guys, in circular motion the second biggest confusion is what is centripetal acceleration, what is centripetal force, what is centrifugal acceleration, what is centrifugal force. ये चारों की खतरनाक वाली खिचड़ी बनती है. So let me clear you out. For question solving purpose, you are supposed to consider only centripetal acceleration. Either you are supposed to take centripetal acceleration or you are going to take centrifugal force. Okay. From your brain, remove the words called centripetal force or centrifugal acceleration. Forget about these words. I will be explaining, लेकिन questions purpose के लिए you don't need to use them. ठीक है. सिंपल सी एक कहानी. What is centripetal force? कुछ भी नहीं है. Centripetal force is nothing. It is what I call it as Spider-Man. सेंट्रीपिटल फोर्स जो होता है that is simply Spider-Man. Why do we call it Spider-Man? Because Spider-Man does not exist. Similarly, centripetal force does not exist. चलो guys, ready for one more story? क्या बोलते हो जनता? To understand the concept of centripetal force, simple सी एक story है. And again, you are never ever going to forget it. सुनना है? Come on, come on, कोई reply नहीं है. So, to understand the concept, okay, let's say you are a big shot Hollywood director and you want to make a movie called Spider-Man. Obviously, there does not exist a real Spider-Man. If you go around the world कि भाई मुझे तो actual Spider-Man चाहिए, you are not going to get an actual Spider-Man क्योंकि actual Spider-Man तो होता ही नहीं है. So what you are going to do? You are going to recruit या hire an actor. ठीक है, यू विल हायर एन एक्टर, उसको स्पाइडरमैन का कॉस्ट्यूम दे दोगे, यू विल गिव हिम द रोल ऑफ स्पाइडरमैन, एंड फॉर योर मूवी दैट एक्टर विल बी द प्लेइंग द रोल ऑफ स्पाइडरमैन. इज दिस फंडा क्लियर टू ऑल? बेसिक कहानी क्लियर हो रही है? Is that actor an actual Spider-Man? No, not at all. He is only playing the role of Spider-Man, that too for your movie only. Your movie gets over, the actor goes to his home, he is no more a Spider-Man. He is back to his actor. He is simply an actor again. Okay? Now, another director might decide to make a Spider-Man movie. Is it necessary that he should hire the same actor? Not at all. He can hire any other actor who is ready to play the role of Spider-Man. Now, exactly same thing happens. Let's say you decide. Yes, Vaibhav. Exactly, practical इसके नाम सभी को याद होंगे. Different Spider-Man movies if you have seen. सबसे पहले आई थी Spider-Man 1, Spider-Man 2, Spider-Man 3. In that there was Tobey Maguire. फिर वो अमेजिंग स्पाइडरमैन आया था. इन दैट देयर वाज एंड्रू गारफील्ड. और अभी रिसेंट में मार्वल वाली देखी होगी, फार फ्रॉम होम, होम कमिंग, सिविल वॉर. इनमें कौन था? टॉम हैलैंड. सो डिफरेंट, ईच मूवी रिक्वायर्ड अ स्पाइडरमैन, but each movie hired a different actor to play the role of Spider-Man. Exactly same things happen with circular motion. ये विधि, ये चीजें याद है अच्छे से. Okay, so let's say you decided to make a movie called circular motion. Okay, now for circular motion, which is the first thing that you require? Centripetal acceleration. For centripetal acceleration, you required centripetal force. Real life में there is no centripetal force. That's why I said centripetal force is Spider-Man. What happens is you will look around for a force which can play the role of centripetal force, means which can provide centripetal acceleration, and that force will be given the title of centripetal force. Very, very simple example. Earth decides to revolve around the sun. Okay? Earth decides to revolve around the sun. Now, since it is a circular motion, Earth ने बोला, I require a centripetal acceleration, I require a centripetal force. You went around in the universe. भाई कोई force है which can provide centripetal acceleration? Which force came up? Gravitational force. Gravitational force said, okay, I am at your service. I am ready to provide you with the centripetal acceleration. So for our movie, for Earth revolving around the sun, gravitational force is providing the centripetal acceleration. So gravitational force जो होता है G m1 m2 upon r square, that will be called centripetal acceleration, which is providing mv square by r. Okay, this is for Earth revolving around the sun. Let's say some other Hollywood director is making a picture Spider-Man. Electron decided to revolve around the nucleus. Electron decided to revolve around the nucleus. What did the electron say? I require centripetal acceleration. Again you went out looking in the universe. भाई कोई centripetal force provide कर दो, centripetal acceleration provide कर दो. Now which force came forward? Come on, अब कौन सा force आएगा centripetal acceleration provide करने के लिए? Electrostatic force. तो इलेक्ट्रोस्टैटिक फोर्स इज प्लेइंग द रोल ऑफ सेंट्रीपिटल फोर्स. चलो गाइस, एवरीवन गेटिंग दिस? फटाफट बताओ, चमका सभी को. क्विकली क्विकली क्विकली, चमक रहा है ये वाला फंडा सभी को. In FBD, you do not need to draw centripetal force separately. What you are supposed to draw all the forces and draw the centripetal acceleration. That's it. Equation F net equals to m into AC. This is the basic funda that you are going to apply. Any confusion, any doubt? फटाफट बताओ इनता. कोई भी डाउट है, कोई भी कंफ्यूजन है, यू हैव 2 minutes, फटाफट पूछो. ओके, वंडरफुल. एक और प्रैक्टिकल एग्जांपल. चलो, नाइस वैभव, वेरी गुड. तुमने एक पत्थर लिया, यू टुक अ स्टोन. ठीक है, ओके स्वराज, जस्ट पे अटेंशन नाउ. You took a stone, tied it with a string, and you wanted to revolve that stone. Revolve that stone मतलब circular motion. If circular motion है, that means you require centripetal acceleration. You went around in the universe looking for भाई कोई force है जो कि मुझे centripetal acceleration provide कर देगा. कौन सा force came forward? Which force? Tension. So T will be equals to m into AC. Means in this circular motion, tension is providing the centripetal acceleration. So tension is given the title of centripetal acceleration. Centripetal force, sorry. फंडा सभी को क्लियर हुआ? स्वराज, वैभव, विधि एंड एवरीवन एल्स, एनी डाउट, एनी कंफ्यूजन? फटाफट पूछो. दिस इज अ वेरी वेरी इंपॉर्टेंट कंसेप्ट. यस वैभव. अब ओमेगा स्क्वायर आर लिख लो या वी स्क्वायर बाय आर लिख लो, दैट्स योर चॉइस, बट दिस इज द बेसिक फंडा. चमक गया सभी को? चलो, नाइस. एंड एज आई सेड, this is the trickiest part in circular motion. Most of the students, what they do is tension लगाया, उसके अलावा they draw one centripetal force as well, which is absolutely wrong. Centripetal force will not be drawn separately. All the real life forces that we know, you are only supposed to draw those force, and that force will provide centripetal acceleration. चमक गया सभी को? चलो, नाइस नाइस. So I hope major confusing points of circular motion are clear to everyone. चलो, नाइस, वेरी गुड वैभव. So circular motion का basic revision वाला part complete होता है. Now as usual is our fun time. Fun time activity. Now today's activity is very very logical. Let's see कितने लोग कर पाते हो. Question is quite simple. थोड़ा सा सोचना पॉइंट है. ठीक है, थोड़ा सा लॉजिकली सोचो. Okay. Now there is a parking row. At what number is the car parked? ये पार्किंग रोज के अलग अलग नंबर है. द कार इज पार्क्ड एट विच नंबर? व्हाट डू यू थिंक? कुछ पैटर्न बनता हुआ सा दिख रहा है. कम ऑन, व्हाट डू यू थिंक? 16, 6, 68, 88, 98. ओके. ओहो, वैभव, बहुत व्हाट्सएप व्हाट्सएप चल रहा है इट सीम्स. चलो, बाकी जनता. एज आई सेड, दिस इज अ कॉमन क्वेश्चन बट इंटरेस्टिंग है. Anyone else? No, Vaibhav, I am not on Instagram. फंडा बड़ा सिंपल सा है. If you try to find a pattern between 16, 6, 68, 88, 98, नहीं जमेगा. The simplest way of approaching is उल्टा देखो. So you can now very easily say कौन सा नंबर होगा यहां पर. 87. ठीक है. सो सिंपल सा क्वेश्चन था. यस, आई एम श्योर मैक्सिमम लोगों को व्हाट्सएप पर आया हुआ होगा ये क्वेश्चन. चलो, नाइस. ओके गाइस, होप ऑल ऑफ यू एंजॉयड द सेशन. सभी को मजा आया. दिस वीक वी आर गोइंग टू हैव अ वेरी इंटरेस्टिंग सेशन. ठीक है, फिजिक्स पर ही बात होने वाली है, बट वी आर गोइंग टू टॉक समथिंग अ वेरी इंटरेस्टिंग टॉपिक इन फिजिक्स. नॉन एकेडमिक ऑब्वियसली. ठीक है. द टॉक शो जो था, जो अपना लैग की वजह से नहीं हो पाया था, दैट विल बी अपलोडेड वेरी सून. अपार्ट फ्रॉम दैट देयर इज अ 3 सेशन सीरीज. स्वराज, इट इज ऑलरेडी देयर. एक बार चेक कर. ठीक है. नाउ द कमिंग सीरीज विल बी अ 3 लेक्चर सीरीज और 3 सेशन सीरीज, जिसमें बड़ा ही इंटरेस्टिंग कंसेप्ट बताने वाले हैं तुम लोगों को. एडवांस प्रॉब्लम सेशन वैभव ऑन थर्सडे एंड फ्राइडे. ओके, सो डू सब्सक्राइब. जितनों ने भी सब्सक्राइब नहीं करा है, वी आर गोइंग टू टॉक समथिंग अबाउट क्वांटम फिजिक्स, टाइम ट्रेवल और एस्ट्रोफिजिक्स. इस टाइप का एक सीरीज होने वाली है इन दिस वीक इटसेल्फ. तो स्टे अपडेटेड ऑन द चैनल. ठीक है. चलो गाइस, आई होप ऑल ऑफ यू एंजॉयड. सभी को मजा आया. ठीक है. 2 minutes, एनीथिंग यू वांट टू आस्क, फटाफट पूछो. कम ऑन, 2 minutes इज अवर बका टाइम. ओह, इज इट वैभव? चलो, बिल्कुल, ऑल द बेस्ट. यस, क्लोज फाइट विथ आरव होती रहती है हमेशा. सो लेट्स सी. चलो एंड करें. लेट्स एंड द सेशन देन. कल मिलते हैं. बाय 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 एवरीवन. आई होप ऑल ऑफ यू एंजॉयड. सभी को मजा आया होगा.